Okay, so we've been reviewing for this final, which has a 9-page packet to review for, but we were on page or around problem 20-ish, and I've heard 22, 24. I'm going to start with 22 just to kind of remind you a little bit. This is substitution. This is the kind where you would put that where x is. It says x equals that, right? So you'd put it right here. I do remember talking about that. Do you guys remember talking about that? Yeah. You'd put the y plus 2 right there in where the x is. And I'm going to rewrite things out. 3y minus 2 times that equals 15. So this is just to copy it down. That's just to copy it down. And then this is where all the action happened, right there. That x turned into y plus 2. Okay, that's called substitution. Why is that the best option? Because you can't do the other ones. Because you can't graph. Why can't you graph? Because they're not y equals. And you can't graph and you can't do the other one, which is called can't eliminate. And the reason you can't eliminate is you get how these aren't going to like cancel each other off. They're not even the same. They're not in the same order. So this one, solving using elimination, I'll start it with you. Do you get these two are exactly the same so that when I put them together, they just disappear? We'll put these two together and put it right here. And put these two together, put it right here, and you'll have one variable left. It'll be y equals blah, 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 and you solve for y. All right, so there's some help on those. Number 24, I do remember starting this one. And this one has a y-intercept of -5. So here, I start at -5, which is right there. And then I do rise of 2, run of 1. So I go up 2 over 1, up 2 over 1, up 2 over 1. And then I remember talking about how since this says or equal to, you use a solid line. And this one, you use a dotted line. Now this one has a weird thing in that it doesn't have a y-intercept. If I put a +0 there, that'll help. This is the y-intercept then. So you start it at 0 and you rise. Wait a minute, how do you rise -5? You go down 5. When you run, this part's called the run, you always go to the right. Kennedy, can you shut that door over there, please? Thank you. All right, so here's a quick start to this one. This one, the bottom one, starts at 0, so I use a different color here. Starts at 0 and it falls 5 and runs 4. And then, I think that's right. Yep. And then it's going to be a shading thing. This one's solid and this one's dotted. And then the last thing you got to do is shade these. So how do you shade them? That kind, the greater, they go shade right. Because right is where the greater things are. Oh, wait, I'm wrong. Shade above, not right. Shade above it. It's kind of to the right of it, but it's greater is above. And that makes sense. If I wanted your height to be greater, I'd go up above you, okay? And this is a less than sign, and so those shade left. Less than and left even kind of rhyme. Okay, so there's some help on 24. Now let's go look at the next page. Everybody get to this page, please. So on this page, we're talking about feeding the function different things. On number 1, EJ, what function are we even talking about? The f function. Good. There was a g, but we're just going to ignore it because this problem only has f in it. So then I always like to take this and write it with an empty spot where the x was. Do you get how this is very similar? But I put an empty spot where the x was. And then you drop in a number. They want me to put in 3, so I put in 3. These guys kind of get challenging when they get over to things like this, and you're like, where do I even start? Well, find f of 3, stick a 3 in the f function. Find g of negative 8, and then later, you do this later. But first, you do this. And then second, you do that. And then you do the minus after you got the other two answers. Okay? Here's a little advice on this one. Do this first. First find f of 5, and then you'll have an answer like, let's say it's 10. Then, once you're done with that, you put that answer here. I'm going to find f of 5 real quick. I'm going to put a 5 right here. That's 2 times 5 is 10 minus 1. So y equals 10 minus 1 is 9. When I put in 5 for x, I got 9. So that's a 9. All right. The charts. F of negative 2, I'll remind you how that works. Here's the f function. You might be able to, but there's no negative 2 in there. That's not where you're supposed to look for that. This is where x is negative 2. Okay, so there's the f function and the negative 2. That's like this right here. And so then I like to think of it as where do they cross? F of negative 2 is 9. It's like where you're seeing where those two things cross on the chart. But what if it's got a double? Let's start with just g of 1. So then you go, okay, I guess I'm using the g function of 1. And a really common mistake is people are like, oh, sweet, this time there's a 1 in there. That's not the point. That's the g function, and here is the 1 you're looking for, because that's where x is 1. So then you go like this. And hopefully you can tell from this that g of 1 comes out to 0. Now it's f of 0. So you do the thing on the inside, and then we go to the outside and we have to do f of 0. Okay, some tips for 28. Again, I'll help you individually too, but please keep up with me here. Everybody look at number 28. If I wanted to do f of 2, look close. Did they just tell me that x was 2 or that y was 2? They just told me. How about this? Why don't I write this out? Would you guys all agree that f of x is what's supposed to be there? That's f of x. So I ask you again, did they just tell me that x was 2 or that y was 2? X is 2. Yep, see? They just told me that x is 2. So if they just told me x is 2, then we got to figure out what f of x is. Would you agree that f of x is y? See, f of x is y, isn't it? So then your y value is over here. So we got to figure out y. We don't know y. We know x is 2, but we don't know y. So then we go over here. Now that we know x is 2, that's our spot. And it's 2 comma 2. So x is 2 and y is also 2. All right. On this one, it's just a complete repeat of what we just did. They told us that x is 1, we go do it. On this one, they're telling us that x is 2. And then you go find g of that. One of these lines is g. Oh, it's this one. And you're finding g of 2. And then you'll get an answer. And you'll do f of that. So first, do this first. And if you come up to ask me questions, I'm just going to say, did you stick 2 into the g function and figure that out first? That's what you'll have to do first, is figure out when you stick 2 into g, what do you get? And then you're going to do f of that. This part gets done second. All right, moving on to this page. This is probably the most powerful graphing technique that there is. Like we use this, I just got done preaching a pre-calc class before yours. We're at the end of the first semester and there were multiple graphs just like this where you had to pick X's and Y's and figure out what the graph looks like. So if I give you this is 0 and 1 and 2, would you be able to go put that in this function here and figure out what their Y is? Remember, f of x together, f, not just the x, but the f of x, that's a y. So if you want to write y equals right there, that might be easier. And if I stick in 0, y will equal 0 squared, which is 0. So 0, 0 is one of your points. Now, I'd love it if you memorized what this looks like and you can be like, oh, I know it's perfect, it's right there, but that would be super sloppy and that's not right. Yes, it's kind of a parabola, but you'll need to get exact points. And again, I'd love for you to know that square roots, I remember that. It looks kind of like this. Okay, that's great, but it's not exactly right. You got to find exact points on it. So stick in numbers for x and y. You want to stick in 0, it works. Square root of 0 is 0. Square root of 1 even works. But as soon as you get to 2, I hope you go, wait a minute, I don't even know the square root of 2. Then don't use 2. Use maybe like 4. And they want you to do a couple more, so use perfect squares like that. All right, that's what you do for all of those. Once you see the picture, the domain is left to right, and the range is down, like how low it goes, to up, like how high it goes. When you see the picture, you get these from the picture. All right, last thing we're doing today, and then the second half of our class will be just you coming up and asking individual questions. We're going to finish off this page. So number 30, I'm going to give you some hints on these again. Horizontal inside, vertical outside. So that's 7 there. That's telling me to do a horizontal thing, which is like right or left. This one's right 7. And this thing is telling me it's a vertical, and do you guys remember the name for that?
Stretch.
There's stretch, there's shrink. Which one do you guys think it is? Stretch. If it was on the inside, that 2 would do the opposite of what you would think, and so it would shrink. But that 2's on the outside, so it's a vertical stretch. This one's on the inside. Seems like it's going to make it smaller. Actually makes it bigger. Because it's on the inside. They do the opposite of what you think. All right. And this number 31, that's where you just write equations. This is not the right answer. But I'll make one that's similar. That is wrong. But your answer is kind of like that. It's an equation where you just put in the 8 and the vertical shrink of 1/2. This is totally wrong because I did it on the inside, which is horizontal. I didn't use 8, I used 7. So you have to fix it, but it's kind of an answer like that. That's all they mean is write an equation like that. Okay, so we've had a chance to practice a little bit there. Hope you were paying attention, taking some notes on your packet. And remember that we still have a whole day tomorrow. In looking at it, maybe we'll have to do a little bit after lunch because we still have pages 6, 7, 8, and 9, which is 4 more pages. That'd be a lot to do in one day. So we only have 1 day left to study. So I strongly recommend that you get it all the way finished through problem 31. At least try to get there before lunch. Then after lunch, I guess I'll have to pick up and do 1 more page. If I can do 1 more page after lunch, then we only have a few pages left. We can handle that all tomorrow. All right, so I'll pick up after lunch. Can't leave yet, but soon. So, okay, we're back from lunch, and I only have 1 more page I got to look over with you, and then you're going to have a lot of work time where you can ask me questions and stuff. So try to stay focused for just probably 5 to 7 minutes, maybe at the most. Okay? All right, so here we go. So on this first one is number 32. It should be the top of the next page. I know for most of you this means just scrolling a little bit. For this one, I'm going to suggest that you just graph the parent one, see what it looks like, and after I graph that, I graph this new one on the same graph, and I go, okay, what happened? Did it move up? Did it move down? Did it move left? Did it move right? Okay, so let's just graph these points. And I know we don't have a perfect graph. Just draw one in like me. And then, where's negative 2, 2? All right, so I'm going to go negative 2, 2, and I put a dot right there. And then negative 1, 1. And then 0, 0. And then 1, 1. Oh, I recognize this one. That's the V shape. I've seen that a million times. It's called the absolute value graph. Okay, so after I've graphed that, you know half of what you need to know. You know that this thing is a V shape. But now I got to figure out where it's been moved to. So I'm going to graph these points. For those that just arrived, I find we've moved on to problem 32. We realized that the first thing we graphed was a V shape, like an absolute value. Then I'm going to graph these. Now that's negative 3, negative 2. So I'm going to go over negative 3, negative 2. It's down there. And then 4, negative 1. 5, 0. Oh, I see what's going to happen. It's like this. So do you see that the original one's a V-shape that looks like this, and the second one is a V-shape that looks like that? Do you get that's been moved to the left and it's been flipped over? So you got to be able to analyze the two graphs. The first one was this V-shape, the normal absolute value. The second one has been changed. So they ask what transformations are happening. Well, it moved left for sure. Okay. Uh-oh. I'm just double checking my work. I moved it the wrong way. Darn it. Okay, so everybody, erase this one. My bad. It doesn't actually go there. It moves somewhere else. It goes to 3 to the right and down to there. 4 to the right and down 1. 5 to the right and 0. Okay, sorry about that. It moves this way. So it goes from here, moves over there, and then flips over. So what would a new equation be for this? Well, I know it was a V-shape still. And you figure out what to put in here and here, and maybe even here, to make it flip upside down like this. See how it's going upside down? And move over to the right. So if you graph those two, you'll be able to see what happened. Now you could have actually just like thought it through and said, look at how all of these numbers actually just turn negative. But then you're going to have to think through, like, if all my y's turn negative, what kind of reflection is that? And I think that's harder. I personally think when you look at it, you go, oh, it's reflected, it's flipped. All right, so your final answer is this equation, and you got to figure out where to put where to make it do that. Flip over and move to the right. Okay, and now this, we practiced this so many times, I'll be extremely disappointed if you can't put in 0 and 1 and 2, and maybe even a couple negative numbers, like -1, -2. Because once you start putting them in, you'll go, okay, I put in 0, and Mr. Server, I got square root of 0. Does that exist? Yes, it does. Square root of 0 exists. It's 0. 0 plus 7 is 7. Some of you guys aren't writing on your iPad right now, and I want you to, because I've just helped you with a bunch of stuff. Number 33 is what we're on right now. Okay, now we're going to put in 1. when I put in 1 in this equation right here, then square root of -1. Square root of -1 can't exist. There is no square root of -1. So then this was a bad point to pick because you can't do square roots of negatives. And some kids can't think that, oh, the whole thing is, then you can't do the whole thing because it's got a negative under the square root. Nope. If you put in negative numbers like that, when you put in a -1, then you have -1, and then that's square root of +1, and then that's 1 plus 7, and then that's going to make 8. So I'll give you a couple of numbers that'll work better than what I picked the normal ones to start with. But then I realized you got to put in negative numbers or it's not going to work. So I'd put in -4, because then you got negative of -4, and that actually works. You know what I mean? -9. -16, I guess. It's a little weird, but it would work. Goes off the graph, I know. So maybe on this one, you didn't even have to have that last point, but there are some points I would put in on that one. On this one, much nicer numbers, because you don't have to worry about taking square roots. So you can pick anything you want. I always suggested you get it close to 0 on the inside. So if I put in -1, that's the perfect point. If I put in 0, that's still going to work pretty good. If I put in -2, that makes it work pretty good. Maybe even +1, +2. All right, there, we've made it to the end of that page. That for tomorrow means that we'll start here, and we will just have a couple pages left to talk over. And then your job is to tonight try to get through the whole packet, even the part I haven't talked about yet. Just try to get close anyway. And then remember that you're going to have to turn this thing in on the last day. That's really important because it shows whether you're trying or not. To be honest, how much mercy do you think I have for a kid who doesn't do the review packet? And then they do bad on the test. Am I going to be like, oh, poor kid tried so hard and didn't do well? I'm not going to have much mercy. If I have a kid who did all the problems and then asked me questions in class, that's a whole different thing. Then if they really struggle on the final, I might be like, oh, at least I know they tried really hard. And then I can think that through in the grade. But kid who doesn't even do this thing, well, they don't even try. Why should I give them any break? They're not even trying. Why should I help? Okay, so think of it from the teacher's perspective. And this is true in all your classes. As we see you going into this last test, if we see you trying really hard, we're going to treat it totally different. How can I tell if you're trying hard? Did you do the practice? Did you do any studying for the test? So you're going to turn this in the last day. So do your best. That's all I can ask. All right, that's all I have for you for the video for today.